Okay, guys. Good morning. Let's go ahead and get started for today. Okay, so today we're going to do example 14.7 and 14.8 in your textbook, and that'll be due next Monday, May 11th. Okay, so here's that one. And so you'll need the example 14.7, 14.8 document. Okay, and the first spreadsheet we'll need is the pharmaceutical sales, so you can open that one up first. And then the soft drink one is the second example. And so I think you guys saw the email I sent you, but just in case you missed it, I put all the videos on YouTube that I've done for the recordings. And so just in case you missed something or missed a class, you should be able to go see it on there. And so it just shows exactly what we cover via WebEx. So hopefully that's helpful if you need that resource. Okay, so let's, you can open up example 14.7, 14.8. And you can open up the pharmaceutical sales Excel template. Okay, so we're going to examine a couple more exponential smoothing techniques briefly. And so we learned about the simple exponential smoothing last Wednesday, I think. And today we're going to learn about a couple more types. We're not really going to do the full analysis of these types because you need a different software package. And we only have the basic Excel, and some of you already have that. So I just kind of going to show you what these techniques do. And we won't spend too much time on these two types, but it's important to know there's additional types of exponential smoothing. And so we're going to learn about Holt's method, which is for a trend. And then there's a Holtz-Winters, which is for any seasonality or kind of when your data repeats the same cycle in the season. So there's some optional videos if you want to learn more about Holt's exponential smoothing, which is again for a trend, and Winters, which is for any seasonality. You can look at those. And so let me introduce the example 14.7, or the introduction. Okay, this is forecasting quarterly sales at a pharmaceutical company. So the file pharmaceutical sales, which is right there on Blackboard, contains quarterly sales for a large pharmaceutical company from first quarter 1998 through the fourth quarter of 2007 in millions of dollars. The time series plot, which we're going to do, indicates a fairly consistent upward trend. So we're going to use a trend forecasting method. And the question is, can Holt's method be used to provide reasonably accurate forecasts of this series? Okay, so in the pharmaceutical sales text or Excel template, you see the quarters for each of these pharmaceutical sales. Here's quarter 1, 2005, quarter 2, 2005, and all the way down. Okay, and we're trying to forecast the 8 quarters after. Obviously, if we did this now, we'd have to update our data, but assuming this is 2014 and we're trying to forecast the next couple of years, then this is what we're trying to forecast here. These quarters, 2015 and 2016, 4 quarters per year. And the data, this is the associated sales data that we have observed each year. So we're trying to predict what our sales will be in the coming quarters, and in particular the next 2 years. Okay, so let's start example 14.7. Forecasting quarterly sales at the pharmaceutical company using pharmaceutical sales spreadsheet. And so step 1 is just to create a time plot. So let's see why we're going to use the trend, and we'll see that we have a trend in this data. So you can make a time plot, step 1. Just the pharmaceutical sales data over time. Okay, you can just go to A1, and to select all, you can hit Control A. Oh, sorry, don't do that. We only want the A and B columns. So let's just do it manually. You can select the A and the B column to show all the sales over time. All right, so we're going to, even though the sales has not occurred in the quarters, the years 15 and 16, we're going to select it because we're going to add some additions, the forecasting data to it later in the exercise. So for now, just select A1 to B49. So select all this data that I have highlighted, which is range A1 to B49. All right, and let me just make a simple time plot or line chart. Go to the Insert tab, and then Recommended Charts. And they don't have the one we want, so click on All Charts. And you want the line chart, and just the default one is fine, just a line like that. So line chart, and hit OK. Okay, so there you go. You can see that this is the sales over time, and it's not exactly a perfect trend, but there's clearly an upward trend. And so if we expect this to continue, we can model it as such and have the trend kind of be extended upward, but there's going to be a little more weight on the more recent data. So it won't just be like a linear regression. It's going to be a more weighted trend I guess, if you will, based on what's happened recently. So we're going to use Holt's method because there's a clear upward trend. You could also use it if there's a downward trend, but here we have an upward trend. And so we'll use the Holt's method for a trend because we see a clear trend in the data. So you want to make sure that if you're using these specific methods that you have the type of data that you want to use it for. So here we have a trend, so we're going to use the method with the trend. Okay, so we're going to estimate the simple exponential smoothing that we did last time and then compare it to the Holt's method. And like I said, you don't have the add-ins or the capabilities to do the Holt's method with Excel, or especially with Excel Online. So I just did it in another software program called R, and I put the forecast into the spreadsheet. So the Holt's method forecast should already be in your spreadsheet right there with the MAPE, but I just wanted to do the simple exponential smoothing, which we can do in here, and compare it, and we should see that this one is better. But you can't do it in basic Excel without an add-in, but there's some other free software programs. I use R or RStudio, and that's beyond the requirements for this class. But if you're interested in advanced forecasting methods, I've taught some classes on that, and you can contact me if you want more on that. So the software program again I use is called this. You're not required to look at it, but it is a free software. It's pretty useful for forecasting and other types of statistical analysis. But for this assignment, let's just calculate the simple exponential smoothing and compare it to the Holt's method, which is already there. All right, step 2. Let's generate an exponential smoothing with alpha equals 0.9. And including the APE. All right, so we did this last Wednesday. But here's how you do this. So you want to set up the exponential smoothing equation just like last time. So C1 is blank, C2 is blank. In C3, just type in equals B2. Start with that, so equals B2. And then starting here in C4, let's specify our exponential smoothing equation with alpha equals 0.9, which means the 1 minus alpha is 0.1, but it goes like this, equals, parentheses, alright, so 0.9 times the first observation, or the previous observation, which is C3, alright, close that parentheses, and then we want to have a 1 minus alpha, which is 0.1, times the previous exponential smoothing forecast, which is C3. So the full equation is this. Equals 0.9 times D3 plus 0.1 times C3. Alright, so we did the same exact thing a couple times on Wednesday. The only difference here is I changed the alpha to 0.9. I think last time we had an alpha of 0.1 and 0.5 maybe, but same process. Just you're specifying the alpha and the 1 minus alpha, and so here it's 0.9 and 0.1. Okay, so let's, if you have this equation, we can apply that down the whole column. So you can just grab C4 and drag it down all the way to the 1 month forecast. So just drag it down like this. All the way to C42, and if you click on C42, you can see that your next forecast is 0.9 times the previous observation plus 0.1 times the previous forecast. So you should get that number, 8,234, and so C42. So double check that. Okay. Everybody get that? Alpha 0.9 ohms. Okay, we are going to calculate the APE and then the MAPE for the alpha 0.9. So starting in E3. Alright, so we've done the APE formula a whole bunch of times, but the same thing. So V3 equals, like V3 is in dog, equals absolute value, and then add another parenthesis. Okay, so the absolute percentage rate is the absolute value of actual minus predicted over actual. So it's the absolute value of V3 minus T3 over V3. All right, and if you got that APE formula, you can take V3 and drag it all the way down the column. So drag it down to D41 to get your APE. Okay, and then I made a little spot to put the MAPE, so let's calculate it there. All right, so in D51, let's take the average of the APE column, so here equals. So the average of D3 to D41. Okay, so I got 4.62%, and you should get something similar. Okay, is everybody good so far? All right, step 4 is the conservative. So I put the Hulk method forecast here for you, and the APE. All right, so it's actually pretty close, but this one's 4.62% and this one's 4.40. So we probably have to do some, if we're really doing like a research project or paper, if it was this close, we have to do some additional error checking. But for this purpose, this one's lower. Let's choose this method because this is the method we're learning about. It holds trends. And let's say we're going to choose this one because it has a lower error, which it does. 4.40 is less than 4.60. Okay, so therefore we're going to use the prediction for the Holt method which I've provided here. Yeah, okay. So we are going to choose those. Those are our next eight quarters of forecast. And so let's go ahead and so that's our forecasting method for this trend. And the last step for this analysis or this exercise is to show the graph or we already have the graph of the time plot. So let's add the forecast to that graph so we can see the Holt method forecast on our graph. Okay, so what you want to do is okay, so click on your time plot if you have it like this with the sales, and then just right click it and choose select data. Okay, so see up here in the chart data range, you can see that the data we selected previously is already on there. Let's just update the range to include the Holt method forecast, and then it'll be on the graph so we can see it. So just click on this chart range button. Okay, and with that selected, hold down the control button on your keyboard, and then manually select the entire Holt method column like this. So hold down control, and then select all of this. So if you hold down control, it should add a second range. So I've selected basically A1 to B49 and E1 to E49. So if you have both of those are selected, and to select non-consecutive columns, just hold down the control button and then use the mouse or the keyboard to select it. So those are the ranges, just again, for range A1 to B49 and range E1 to E49. Okay, so if you got that chosen, go ahead and hit that button there. Yeah, I can do it again. So, okay, so we'll start with the charts that we already made. So does everybody have the chart from the previous, from step one? I can do the chart again too, just in case. Okay, so the time plot, step one was just a graph, or we did a time plot of sales. So all you have to do is go to, this is step one again. So we selected A1 to B49 and just did a simple line chart. That's what we're starting with in step one. Alright, so now to select the additional range, just click on the chart and right click it. and hit select data. And the right there where it says the chart range data, click on that button to choose more. And leave that selected and hold down the control button. So it's basically control plus select the range. Alright, so we'll see that. So hold down control, then select it like this. Okay, so see in the select data source, this is A1 to B49 and E1 to E49. So you should have that selected. And then hit this button and hit OK. Okay, so it puts the host method in the chart, and if you want to see, you can make a nice little label to see it. So if you click on the plus sign for more elements, or chart elements, and choose see how there's a legend. And you hit that arrow, and I usually like the one on the bottom, but it's really up to you. So I chose the legend and then the bottom option. Okay, so that should look nice where you have, so your forecast isn't going to be perfect because of all the fluctuations, but you can see that this is the data over here. So this is, actually let's add chart axis titles as well so we know what this is. So this is sales in millions, and this is the quarter. So if you click on the plus sign again and choose axis titles, okay, let's just call this sales in millions. And this is the respective quarter, so you can give it that title. Okay, so there you get a nice graph where you see you have the sales in millions. That's what the sales are in. See this indicator here? Sales in millions, the data over the quarter, or over time by quarter. And the blue line is the actual data, and then the red line is the whole forecast for the next 8 quarters and the next 2 years. Okay, so did you guys get everything for the chart there? Okay, so we have another one today, but we're pretty much done with this one, example 14.7. So let me know if you need anything else again for this one. If not, we'll move on to example 14.8. All right, and so again, the point was to see that the data has an upward trend, and then use the method with the forecasting trend to extend the forecast. All right, so you can see that the upward trend is continued when the red line goes into the future and predicts at least the overall level of continuing the upward trend. Okay, so this one is done. Let's go ahead and save this. All right, so that, along with the next one we're about to do, goes in here, example 14.7, 14.8. So that's due next Monday. Okay, let's open up the next one, soft drink sales. This is under the example 14.7, 14.8. Just open up that Excel file. All right, so this is forecasting quarterly soft drink sales using the soft drink sales file. So let me read the little descriptor where the data in the soft drink sales file represents quarterly sales in millions of dollars for a large soft drink sales company from quarter 1 1992 to quarter 1 of 2007. As you might expect, there's been an upward trend in sales during the period, and there is also a fairly regular seasonal pattern shown in this figure, and that we'll graph in the data. So obviously, for things like ice cream and soft drinks, or things that you consume more when it's hotter out, there's going to be a trend of more sales in the summer months, or the hotter months, and probably less sales in the winter, because less people buy ice cream, soda, etc. when it's freezing out. Okay, so you see that in the warmer quarters, 2 and 3, there's higher sales. In the cooler quarters, 1 and 4. So 1 is like January through March, and 4 is October through December. The colder time, there's less soft drink sales. So the question is, how well can this Holtz-Winters method track the upward trend and the seasonal pattern? So we're going to use another method for seasonal forecasting. And so seasonal means, see the data here? You see the fluctuations where in every summertime the sales go up, and in the wintertime the sales go down, and so we can expect that behavior to continue, so we'll use that in our forecasting methods. Okay, so soft drink sales, open that up. Okay, so here we have the quarter and the sales, and again we're trying to forecast the next 8 quarters or 2 years. So here's the next 8 quarters, 2015 quarter 2 to 2017 quarter 1, and I already did the Holtz method forecast for you. I'll put them right here. So this is the Holtz-Winters for seasonality. So Alright, so if we had a trend, so we used the whole linear trend method, which we did last time for the pharmaceutical sales. And if you have seasonal data, which we have now, we're going to use the whole winters. And this is for seasonal data that kind of repeats the seasonal behavior. Okay, and again, I did this in the RStudio software, so you're not going to do it in Excel because it doesn't have the add-in, but you can see what it looks like. All right, step one is to make a time plot of quarters of sales over quarters over time. So you can select A1 to B. Looks like A1 to B70. So select A1 to B70, the whole range, including the quarters that don't have the sales, because we're going to throw in the whole winter's forecast after we do the analysis. So select A1 to B70. Let's make another line chart. Insert tab. Recommended charts. There's the one we want. Just choose that first one and hit OK, the line chart. Alright, so there it is. You can see that the sales kind of repeat this boost in the summer and drop in the winter, and we can, unless something crazy happens, we can expect that behavior to continue into the next 2 years. Alright, everybody good so far before we do the simple exponential smoothing for this? Alright, step two is let's do the simple exponential smoothing, which we can do for this and compare it to the other. And this one is going to be a lot worse because it's going to be hard to capture the seasonal pattern with a non-seasonal model, and so we'll see the difference when choosing the Holt winters. And the two researchers or mathematicians that came up with this or coined it, last name Holt, and the other guy was last name Winters, so they got the credit for this method. Okay, so let's do the forecast for alpha 0.9 in C column. So same process that we did in the previous example. So starting in, so C2 is blank. In C3, type in equals D2. Enter. And then here, let's specify our exponential smoothing, which is alpha 0.9, and the 1 minus alpha of 0.1. So here in C4 equals. Parentheses 0.9 times D3 plus another argument. 0.1 times D3. So we have alpha times the last observation plus 1 minus alpha times the last forecast. So for specific formula is equals 0.9 times D3 plus 0.1 times C3. Alright, enter. If you got this one, go ahead and choose C4 and drag the formula down all the way down the column, including one additional month. So you can drag it all the way down to C63, and if you click on C63, you can see that the next month's forecast is the same process. Okay, 0.9 times the last observation plus 0.1 times the last forecast. So the same exponential smoothing equation we've been using, just different data, and we specify the alpha, and you automatically specify the 1 minus alpha because it's the remainder of 1 minus alpha. Alright, so you should have in core 2, 2015, for alpha equals 0.9, you should have that 4,562. I think that's correct. Okay, so everybody got the alpha 0.9 forecast? Alright, so let's calculate the APE, alright? Same formula, starting in D3 equals the absolute value ABS. This is step 3, equals absolute value of, remember, actual sales minus predicted sales divided by actual. So, add a parenthesis. There's your equation. Equals the absolute value of D3 minus C3 divided by B3. Right? Same formula as we've been doing, and we should get some percent error. 23% off, and if you have that specification equation, click on D3 and drag it down the column. Right, all the way to D62, sorry, for all of the actual dated rows. And then I made a slide here to calculate the MAPE, and we can compare it to the other methods. So in D72, just take the average of the APE column, so equals average. Equals average of D3 to D62. Alright, so the average APE is the mean APE, which is the MAPE. Okay, so we get, everybody gets something like 10.33% for the MAPE. Okay, step 4 is to compare them, and you can clearly see that this one, the error for the simple exponential smoothing is about 10%, where the other one is about 5%. So we're going to choose the one that's better, a lot better. So you can do some other error checking if you wanted to, but you're probably going to get this one being, if it's this far off or this much better in error-wise, then you're going to probably choose this one. So let's go ahead and choose the Holt Winters as our best forecasting method for the seasonal data, which is these numbers here. All right, what we need to do now is add the Holt Winters forecast to the original chart, so it looks nice, like we did the previous one, and then we can see the actual data with the forecast, and it'll look like a nice visual presentation. Alright, so this is what we did last time, but go back to the chart and right click it. Okay, right click it and hit select data. Alright, and then up here where it says chart data range, hit this button to add some more data. Alright, so again we're going to hold down the control button and then manually select the E column. So leave that selected and hold down control and select E1 to E70, holding control at the same time. Okay, so you should have selected A1 to B70 like you had the first time, and then also comma E1 to E70. So you're going to add the E column, right? And you're going to hold down control to select non-consecutive ranges. Okay, if you got that, you can hit this button and hit OK. All right, and so we'll make labels and titles in a minute, but you can see that the forecast that we predicted is something similar to what we see in the data. So it looks like a pretty good forecasting method if you have a seasonal pattern. Okay, did everybody get the Holt winters added to the chart? Okay, so if you have that, the next thing is let's add the legend again so you can see which is which. All right, so click on the chart, click on the plus sign for chart elements. And then down where you see the legend, click on that arrow. All right, so I'll choose legend and then the bottom option to put the legend down at the bottom. So the blue line is the sales data over time, and the whole winter's forecast is the red line, right? And the last thing we'll do for this chart is to add the title of the sales on the y-axis in millions and the quarter on the x-axis so we know what we're looking at. All right, so click on the chart, click on the plus sign for chart elements, and then just choose axes titles. Okay, so this is again sales in millions, so we can just manually type that in there in the title. And this is the respective quarter. All right, so there you get a nice graph that shows the sales in millions over the quarters, the historical data, the blue line, and then what you think or what your best Holt Winters prediction is for continuing the seasonal trend. And so that the red line is what your best guess as to what the sales will be in the next few years. All right, so it's really a nice method if your data has this seasonal pattern. Okay, so everybody gets the chart for this one and everything else? Okay, let's save this one, and this goes in the same discussion forum. Okay, so the ones we just did, example 4.7 and 14.8, they have their own, they both go in the same discussion forum, and those go right there. And like the syllabus says, those are due next Monday, May 14th, or sorry, May 11th. Okay, so we're done with these examples. What I did, I knew this wouldn't take too long because I had done the forecasting methods previously. So we have a few. We didn't get to some of the practice problems from last week, so let's do a few of those because the exercises from last Monday and Wednesday took longer than today's. So if you go Okay, we can start with these ones because we just did the exponential smoothing. So if you click on example 14.5 and 14.6, we didn't get to the practice problems, so I've already solved them, but let me just go through these because I want to make sure you're prepared for the upcoming final exam if this is on there. So example 14.5 and 14.6, we did the example in Excel, but we didn't look at the practice question, so you can open that up. Okay, so this is from a previous exam, but here you have a screen cap of your sales data. This is using the hardware sales one we did last Wednesday, I believe. So here's your sales data over the weeks and the moving average 2 forecast and then moving average 4. Okay, and part A was just to calculate next forecast. So part A is what's the week 105 sales forecast using an MA2 or a moving average of 2. Okay, and the MA2, right, is just the average of the last 2 observations. So this is pretty simple, but I just want to make sure you can calculate it manually. Okay, so you're trying to get this one, the MA2 for the next month or year, week, the next week, so week 105. Okay, so the moving average of 2 is the average of the last 2 observations. You can see that the last 2 observations are week 103 and week 104. So 1,903 and 1,702. So if you average those two, that gives you your next moving average of 2 forecast. So here's the calculation. 1,903 plus 1,702, and the average is divided by 2. Okay, so your week 105 sales forecast using a moving average of 2 is the average of week 103 and week 104, so it comes out to about 1,802 and 50 cents. All right, so you just move the average and take the appropriate order, so the average of the previous 2. And then you can see the difference in part B. What's the week 105 sales forecast using an MA4, or a moving average of 4. Okay, and so an MA4 is a moving average of 4. So take the last 4 observations and take the average. Okay, so it's weeks 101 to 104 that you're averaging. All right, so equals 2,361 from week 101 plus 1,658 from week 102 plus 1,903 from week 103 plus 1,702 from week 104. And then take the average of those 4 things, divide by 4, and your MA4 forecast comes out to about 1,906. Okay, so it's a pretty simple method, but just when you're calculating the MA, or the moving average, just pay attention to what number it is. So MA2 is the average of the last 2, MA3 is the average of the last 3, and so on, and then just, that's how you do the calculation, like this. So here's a nice example of an MA2 and an MA4, and you can do the same for any moving average of a specified order. So that was a nice example of example similar to example 14.5. And I got one more for 14.6 on the same Word document. Okay, any questions on this one, the moving average example? Okay, let's scroll down to page 2 on example 14.5 and 14.6 practice questions that are solved. All right, and you can see that this one has the sales data, and I used the alpha 0.2 and alpha 0.9. And I just want you to know how to manually calculate the forecast using those alphas. Okay, so there's your equation. Right? So it's alpha times the last observation plus 1 minus alpha times the last forecast. Okay, so the question is, what is the week 105 sales forecast using alpha equals 0.2? Okay, so the 105 exponential smoothing forecast is going to be, so just use this equation. Alpha is 0.2 times the last observation, which is 1,702, plus 1 minus alpha, which has got to be a 0.8. 1 minus 0.2 is 0.8 times the last forecast for this process, which is right here. 1,077.6 and 89 cents. So if you calculate that, 0.2 times this plus 0.8 times this, you get 1,761 and 91 cents. Okay, so all you got to do is use that simple equation and know which columns you're calculating. So it's just the week 104 actual data and the week 104 actual forecast. And then you can check that you can do the alpha equals 0.9 as well. So what's the week 105 sales forecast using alpha equals 0.9? Okay, so now I'll use the same equation. So alpha is 0.9 times the last observation. That's the same number. Okay, the sales from week 104 were 1,702. In this case, 1 minus alpha is 0.1. All right, 1 minus 0.9 is 0.1 times the last alpha equals 0.9 number, which is right there, 1,884.17. And so if you calculate that, we get 1,720 and 25 cents. Okay, so you can start with the general equation, and you can calculate exponential smoothing simple forecast for any alpha, and just know how to use that simple equation. And then the last part, part E, what does the alpha do specifically in an exponential smoothing model? Okay, so you can look at the equation and know that the alpha is multiplied by the last observation, and so the higher the alpha, the more weight, the more the averages, the more weighted averages going towards what just happened. So if you think the last observation of data is more important, you increase the alpha. If you want the overall series more weight on that, then you can decrease the alpha. So therefore, when the researcher increases alpha, more weight is given to the last observation, and so alpha ranges from 0 to 1, where value of alpha equals 0 would imply that 0% of the weight is given. And obviously the other extreme is alpha equals 1, then it's just equal to the last observation, and 100% of the weight is given. So if you understand the extremes, you can see that the more weight you give to alpha, the more weight you give to the last observation in your forecast, and so on. So it's got to be somewhere from 0 to 1. And now you can see what the alpha does in an exact calculation. Okay, so any questions on the exponential smoothing example or calculation? Okay, so I think that's enough for today. We did example 14.7 and 14.8. That's due next Monday. On Wednesday, we'll do a little exercise using some of the forecasting methods and using some simple stock market data. So we'll do that on Wednesday, and then both of those things will be due next Monday. But yeah, that's what I got for today, and thanks for joining. And let me know if you have any questions. But we are wrapped up for today, so thank you guys for coming, and I'll see you on Wednesday.